Hi, my name is Joseph Bolduc, and this is my demonstration of my project for the project report. I hope to make this video brief. This is my second take. So this is inside of the game engine that I made. It's an OpenTK. I'm sorry for the unserious nature of the graphics here because um, graphic design is not my passion. So some features of the engine, textures, obviously, as you can see all around. There are textures around me. Specular reflection mapping, so you can determine how shiny an object is, or the specular tone normal mapping. So I have a normal shader, so you can see here. Wow, normal's cool. Um, UV and world space textures, which I'll show in that room over there next, and directional and omnidirectional lights. So these spotlights here, they'll shine on the walls, cool. And I have a couple normal lights in here lighting up the whole scene. And that's most of what the engine is. So the game engine, which is not the primary part of the project actually, which is actually kind of a small part, but I did spend too much time on it. So it's an OpenTK using which is the OpenGL C# bindings, and it uses this other miscellaneous library for loading images and the Learn OpenTK documentation as a starting point, because the point is not to focus on the engine. I wanted to focus on the mapping tool, but I spent way too much time on the engine. So for the engine, I used the Godot game engine as a starting point and C#. So moving on to the first demonstration, triplanar coordinates and world coordinates. So on the left here we have a brush or map object that is done in world coordinates, texture world coordinates, triplanar mapping, and on the right is in UV coordinates. So you have the UV defined, and then it does it properly. Whereas on the left here, um, they're done in world space. It's still done in the shader. It's pretty gross, but yeah. So the benefit of having world coordinates is, say, for example, this wall right here. This wall is made up of three different cubes that are all combined, or that are all like squished and combined into the door. So the textures all blend seamlessly, unlike something like these metal, which is the arch here. As you can see how like the texture is angled. Um, so I know you've probably seen a lot of horror maps or horror games as part of the demos, which probably sucks. But I decided I'll throw my hat in the ring. Oh my god, Freddy Fazbear is so scary. Whoa! But yeah, anyway, the point is this supports transparency. Uh, cool. So something I'm not very happy with is, well, this is Z fighting because this map ink tool that I made is not very good. And yeah, but there's also some issues with certain materials. Let me find it. Like say on this crate, there's like a lot of flickering. This isn't Z fighting. I have no idea why this happens, but I only noticed this 2 days before the due date, so I can't fix it because I don't have the time or resources to. So apologies for all the flickering. Not from the Z fighting, though I do apologize for that. That is my fault. So I will now go ahead and show you the actual engine here once I can jump up to this control room. So this is the oh my god, I'm slipping all around. Jesus. This is the control room. So that's what the map editor looks like. I'll tab over. Bam! Map editor. So you're able to save, load, and reload maps. So that just makes a .map file, which is a text file showing all these things. And then you can fly around, do, whoa, cool, all of the textures. So here we have the list in the top right of all the objects that make up the scene. So we have brushes, which are these blocks which can be squished and stuff according to these, this is basically just the transform matrix. We have spotlights, which don't scale, but they rotate and can be moved around, and omnidirectional lights, which I don't have very many of because I don't have shadows on the engine, which kind of sucks. But um, yeah, so you can create a new brush. Let's see, I should create it down here at 0, 0, 0. New brush. Where is it? Here it is. There, yeah. I don't really care about it. And you can select brushes by while you're holding mouse 1, right click. So I want to delete this thing. Get out of here. Oops, I think I deleted something else. Okay, well, I'll just reload later. So there's new lights, so you can just create a new light and it will exist in the scene, and the arrow is just pointing the direction, which doesn't matter for omnidirectional lights. It does matter for the directional lights. And as you can see, they have both the indicator and engine and this nifty arrow. The lighting and like all the rendering is done in the Godot engine. It's like 3D libraries, which I didn't implement, obviously, but all of the matrix calculations for like the transforms are rotated and then are all done by me, and then they're put into the transform objects of the 3D objects in the Godot engine. So next there's oh yeah, so you can just delete and duplicate objects pretty easily. So here I have this point light selected. You can see the thing on the right here change. We can, translate it by some set amount. We can change as well. We can duplicate it, raise it up, have it point down. Okay, I don't know why it's pointing down. 0. Oh wait, no, it's pointing up. I want it to point 90 straight down. And then, hey, we can duplicate it again, and then move it over here. Cool. This is very inconvenient to do. It may look very inconvenient, and it kind of is. And I made the whole map like this. Cool, wow. So other features are changing the material of an object. So this is, I can change this to a brick wall, to, a carpet, metal. I think that was conch wall before. And using world coordinates or not if I want to. So for example, I have like all the ceilings set to world coordinates, or triplanar coordinates. It doesn't show up in the Godot editor for some reason because I don't have that set up, but they do in game. So this checkbox works, and then that's basically all for the project. Thanks for watching the video. Yeah, bye.